Hello, in this video, let's look at a couple more examples of finding surface areas of revolution. Now, we introduced what to do in the last video, so let me just remind you very quickly that we basically have this formula right here. If we're given a function of x and we're graphing it from some interval from a to b, we know that the surface area that you get when you take that curve and rotate it around some other line is whatever the radius is to the center point of that, of each little piece, okay, or basically from the line of revolution, the axis, to the curve. That's r, that distance. And then you have the function y of x, and find its derivative, dy over dx, square it, add 1, square root, multiply by dx. That is that arc length differential ds. And we multiply that by 2 pi. So it's basically the circumference of a center point, 2 pi times the radius, times the length, which is given by that arc length parameter. Okay, so that's a basic setup. So we introduced that, why that worked in the last video. So time for you to try one yourself. So take the curve y equals x to the 5 halves over the interval from x going from 1 to 4 and revolve it about the line y equals negative 2. Find the area of the resulting surface of revolution and set up the integral and approximate the value using a calculator. Okay, go ahead and press pause and work that out now. Okay, so I use the TI-84 this time, and I use my software to my GeoGebra thing here on volumes of revolution to find the surface, to illustrate the surface. So I set the curve at x to the 5 halves for both the bottom and the lower top and bottom curves here, a running from 1 to 4, and that graph the curve here, horizontal axis of y equals negative 2 graphs that line down here. And you can see that if we're taking a point here on the curve, its distance to this axis is always this y value plus 2 more. Okay, and that's for anywhere on the curve. When we rotate that around, we get a shape that looks kind of like this. Okay, it's curved a little on the top. Okay, but it's kind of like a symbol with a hole cut in it. Okay. All right, so in any event, that's what it looks like, but what do we do to compute it? Well, f of x is x to the 5 halves, so f prime is 5 halves x to the 3 halves. This is x going from 1 to 4. So our integral is 2 pi r ds, or in other words, 2 pi. The r is the y value plus 2. The y value is x to the 5 halves. So the r is 2 plus x to the 5 halves. F prime is this here, and when we square it, that becomes, well, there it is. We square it. When we square it, this becomes 25 over 4. And we multiply the powers here, the 2's cancel, we get x cubed. And so I just simply put that in my calculator, TI-84 calculator, and came up with a decimal approximation. And many of the problems, you're only interested in a decimal approximation anyway, so that is what you want to do. Let's try another one. Find the surface area generated by revolving the curve y equals the square root of x minus 1/3 the square root of x cubed from x going to 1 to 3. Revolve that about the y-axis. Set up the integral and use technology to find an approximate value. Go ahead and work that out. Press pause now. Okay, you're back. Hopefully you've worked this on your own. Let's take a look at what we get here. Well, let's see what we have. We have the function f of x is square root of x minus 1/3 square root of x cubed. That in power function form is x to the 1/2 minus 1/3 x to the 3 halves. This is going from 1 to 3. We take the derivative, so it's 1/2 x to the negative 1/2. And then 3 halves times that, the 3's cancel, it's negative 1/2, and power goes down 1, 3 halves minus 1 is 1/2. So there it is. And in this case, if we look at it, since we're revolving around the y-axis, the distance from the curve to the axis is a horizontal distance, which is just the x value. So here's the picture. Here's the curve here, the portion we're interested in. And if you take any of the x's across here, it doesn't matter where it is, the x value will be that radius. Here's what the shape looks like here. Okay, so anyway, the radius is even easier this time, it's just x. And then f prime of x goes here, so we put all of that in here. Now, let me clean this up just a little bit. I'm going to square this. You square the first term, makes that 1/4. Multiply the power by 2, that's x to the negative 1. Square the last, that's plus 1/4. And then the square and the half cancel, half power, that's just x. And then multiply and double for the middle. When you multiply, you get negative 1/4. Oops, that's a mistake there. Let me fix that.